So good afternoon, everyone. Welcome to the second webinar of the VALORADA Capacity Building Program on Copernicus Climate Change Service Support to Regions and Cities. I am Michelle Zhang, and I'm a Climate and Earth Observation Officer at Climate Kick. Before I introduce you to our speakers today, we'll go over a few housekeeping rules. My colleague Antonia will provide you with the details in the chat. To make sure we can respond to all of the questions during the Q&A session, please click the Q&A icon at the bottom and feel free to type your questions there throughout the presentation. Just note that we'll answer them all at the end. If you miss anything, do not worry. Today's session will be recorded and uploaded to our VALORADA webpage for you to review and share with others who may be interested in the topic. I'm very pleased to introduce you to our speakers today. Our first speaker, Sam Allman, works at the European Centre for Medium Range Weather Forecasts, ECMWF, the entrusted entity implementing the Copernicus Climate Change Service, C3S. Sam primarily works on the C3S National Collaboration Program, an initiative that promotes the uptake of C3S at the Copernicus member state level through the co-creation of climate services. Sam previously led the development of sectoral demonstrators designed to provide tailored climate information to sectors such as biodiversity, insurance, forestry, fisheries, and coastal areas. With a background in Earth observation, he previously specialized in satellite remote sensing, focusing on vegetation condition, carbon cycles, and ecosystem health. Our second speaker, Alan Mondrian, is the European Space Projects Manager at Aerospace Valley, the largest cluster focusing on space industry in Europe, which most committed mission is to foster innovation, competitiveness, and dialogue between stakeholders, including for the downstream space industry. The organization's way of doing so consists in democratizing the uptake of space applications for the public sector, a mission at the heart of Alan's activities through EU-funded projects such as Space for Cities and VALORADA, as well as regional and national initiatives. He focuses in particular on the role of space for climate, local and EU policies. Our last speaker, Haley Ponto, is a project manager at Forum Virium Helsinki. She holds a PhD in urban geography and currently manages the Regions for City project, focusing on climate adaptation and social justice. Well, now to kick off our first presentation, we'd like you to answer a question in our poll. This is to understand the kind of user you are when accessing climate information. I will launch the poll now. So for the participants, you're able to find the question in the poll section. And the question is climate information for your region. So there you could cast your vote and let me know if any of you has any problems. Okay, we're sharing the results. And Sam, the floor is yours. You're still muted, Sam.
Perfect. Thank you very much, everybody. And I hope you can see my screen. If not, is that working? Let me know if it is or if it isn't. Okay.
We can see your screen.
Perfect. Thank you very much. Right. Thank you very much, everybody. My name is Samuel Armand. I work at the European Centre for Medium Range Weather Forecasts. As Michelle said, we're the interested entity for the Climate Change Service for the European Commission's Copernicus programme. So today I'll be talking about C3S, Climate Change Service, and how we can support regional adaptation. So the presentation would be broken down really into four main parts. The first is an overview of Copernicus, then an overview of C3S, the Climate Change Service. Then I'll briefly introduce you to the main types of data that can be used for climate monitoring and climate adaptation purposes. Then finally, I'll give an example of how we're brokering data to the European Environment Agency to support their initiatives on the mission for adaptation. So Copernicus is the European Commission's Earth observation programme. So you may have heard of it through the satellite constellations that the European Commission have put up with the European Space Agency. But the Copernicus programme is a bit more than that. So it also implements a series of 6 services. One of these is the Climate Change Service. And the idea is that the services can exploit the vast amount of information that comes from, in amongst other things, the Copernicus satellites. And here at C3S, the Climate Change Service, implemented by ECMWF, we try to make as much use of the available assets that from the Copernicus program as possible to provide support and infrastructure to enable climate monitoring and climate adaptation to see what the possible outcomes for climate change are going to be. And this data is free and openly available, and it allows member states, private organizations, and anybody really to use our information to help mitigate and plan for impacts of climate change. So C3S is more than climate data. We provide climate information. And typically we take all this information from the satellites, from climate models, from other data information, for example, Met station information. We use satellite products from ESA as well. And we import this into the climate data store. And we take petabytes of data and we provide quality information. We make sure it's quality assured. And then we provide this information, potentially even that kilobyte information through applications, through reports, through climate bulletins. So users don't have to go through this whole rigmarole of selecting the best climate information, make sure it's fit for purpose. So the Climate Change Service is really to broker climate information to citizens across Europe and globally. Typically, we have about 70 terabytes of downloads per day, which is a huge amount. And because we've just relaunched our new infrastructure, we have about 50,000 users. And this was down from about 300,000 users a couple of months ago, but it's building up very, very much like 1,000 users a day. So we've got a huge amount of information in there, huge amounts of users, and I'm just going to give you a brief introduction. So it's free and open data for smart decisions. So we provide information about the past, so you can characterize the past climate. You can see how the climate is evolving over time. So we can provide information based on observations and something called reanalysis, which I'll quickly touch upon. And this allows you to characterize the present climate and past climates going back to about 1940. And that's the information we have in the climate data store based on reanalysis. And then we provide some information about possible futures. And here we contain, here the C3S contains information on the seasonal to decadal predictions. So these are initialized predictions that are based on current understanding of our climate, but also we have climate projections. And these are based on the climate models that underpins assessments such as the IPCC climate impact assessments. And I will briefly touch upon those. But this information is hugely important because it does allow us to prepare, adapt, and become resilient for potential climate futures. So one of the kingpins and one of the workhorses for climate monitoring is something called the reanalysis. So reanalysis is essentially our ECMWF weather model, and it's run backwards in time. So we know what the current state of play is, and we can plug in all the information from these observations, and we can constrain the models. We can then fill in the gaps where there been no observations over space and time. And we can provide a very accurate and very reliable reconstruction of the weather going back in time, back to the 1940s. And we do this on every 30 minutes. And it's going back so we can provide weather information globally without gaps, going back at 30 minutes intervals back to the 1940s. And our ERA 5 reanalysis provides this information globally at 31-kilometer resolutions, up to a height of about 80 kilometers. So we can get a full reconstruction, 3D reconstruction from ground level, or 2 meters, up to the top of the stratosphere. This information is updated near real time. So if you go into the climate data store now, you can get the last reanalysis from 5 days ago. Another thing which is useful for climate adaptation especially is looking into the future. So we contain a wealth of information related to climate projections. And these are the climate models that underpin the IPCC, as I mentioned. So we contain global climate projections across various models. So we don't just contain 1 or 2 models. We provide access to the quality assured quality products from the ESGF, which is the Earth System Grid Federation research nodes around Europe, so these or globally. So these contain information related to past climate runs, and future climate runs, and when we can then start to reconstruct future climates. So we contain these global models, but we also have the regional downscaled models from Cordex. And as I mentioned, we do provide a quality assurance. We make sure that the models are doing what they are, making sure the variables are present, correctly named, so that the users can actually access the data through the CDS and ensure and understand that what they're using is fit for purpose. And on top of this, we provide an evaluation and quality control framework. So making sure the data sets have basic checks so what the data set is it's basically fit for purpose, make sure there's no errors, nothing is mislabeled, there's no missing variables, for example. And then we provide an assessment on data set maturity, making sure it's fit for purpose, making sure the metadata has been fully characterized, usable. And we provide user case studies, so provide examples of how it's been used and how it should not be used as well. And this information is going to be rolled out across all the data sets in the climate data store. And this is something that really does set us apart from other initiatives, monitoring initiatives related to climate. So the DCFS data user journey, so people can discover information in climate data store. They can select which data they want. They can request via the catalog or through an API, and they can retrieve the data and they can interact with it. And this interaction of the data can be via applications. It can be via our Python interface called EarthKit, which they can do things online, use our own infrastructure, or they can download the data onto their own machines, use their own existing workflows, for example. So with this in mind, I'm going to introduce you to the European Climate Data Explorer. And here's a link, and there's also a link in the chat, so if you want to have a play of it. Now, the idea of the European Climate Data Explorer is that it brokers information from CDS into the European Environment Agency's Climate Adapt portal. And this brokering of information is to make sure that the users of Climate Adapt and those activities supporting the mission for adaptation get access to climate information, quality assured climate information that's usable for adaptation strategies across Europe and at national and regional scales. Now, the EEA have expressed user requirements through stakeholder consultations. And the idea is that the ECDE, the European Climate Data Explorer, is supporting national, subnational climate and transnational adaptation planning to those regions that don't have sufficient resources or expertise in climate data to do their own assessments. Now, we're really here to provide support and expertise related to climate hazards. So we're not going all the way down to doing exposure and risk assessments at the national scale, but we provide climate impact indicators to allow users to characterize existing climate and possible future climates for many indicators related to heat and cold, wet and dry, snow and ice, and coastal, for example. And we provide information to users through a dedicated application, which I will introduce in a second, but also via data in the Climate Data Store. So as I showed you a version of this diagram earlier in this session, but it really is just to showcase that our information does allow users to really take an assessment, a full assessment of various aspects of the climate system at present, so we can understand the climate variability of today, but also through the use of climate projections, see what possible futures are. So you can develop adaptation strategies based on this information and take into account worst case scenarios, probable scenarios, and look at through an ensemble of climate models, possible outcomes and most likely outcomes using the best information we have available. So the European Climate Data Explorer, the data, if you're a data user, and hence one of my questions earlier is, you can provide direct access to the data that underpins the European Climate Data Explorer. And this information can be found in the Climate Data Store on the Copernicus Climate Change website. And this information can be downloaded directly through the interface, as I mentioned before, or you can sub-select data. So for example, here we're looking at information related to a climate impact indicator called tropical nights. And tropical nights is really a very good indicator of heat stress and it's really important indicator because physiological stresses in humans can really manifest themselves if the body doesn't have a chance to cool down overnight. So tropical nights is a really good indicator to be used in health studies for mortality rates. But it also is one of the key things to see how climate change is manifesting in hot spells, for example. And we provide our data through the CDS, as I mentioned. We provide gridded information and aggregated information related to NUTS 0 regions. Sorry, I didn't stop the, there we go. Gridded information at the national level, but also the subnational, the NUTS 2 regions. Our data is available as NetCDF, which is a proprietary data set really used in the climate science community. And if you're not a particular data user, then NetCDF information can be a little bit hard to use. So that's one of the reasons why we've developed an interface for users. So through this data set published in the CDS, you can choose individual time series from individual models for particular climate impact indicators of your interest. And we have 30 climate impact indicators published in the CDS. And as I mentioned, this interface is designed for data users. An alternative route to access the information is the dedicated application we've produced. And this uses the same information as was published in the CDS, but it provides aggregated data. So you can define, there's a clearly defined baselines. So it will characterize the current climate. And this is based upon the information, the reanalysis period from 1981 to 2010. And this characterizes our current climate. And we can look at particular time horizons for future periods. So we could look at mid-century and end of century for two different climate change scenarios. So business normal and unabated climate change. So the 8.5 scenario. And you can choose between 30 different climate impact indicators. And you get an assessment here on the right of how climate is predicted to change and evolve over time. And it gives an assessment of year by year climate change for a particular indicator, For example, here we're looking at tropical nights in Lombardia in Italy, and on the top right here you can see the reanalysis period going from 1940s to present day, and you can see how the climate change hazards evolving over time, and then you can also contextualize this with climate change predictions, and this is the lower right hand side figure. So you can start to see how the reanalysis, which is the gray line, is comparable to the two climate change scenarios, the RCP 8.5, which is the worst case scenario, and the 4.5, which is the slight mitigation plans, the kind of expected impacts from climate change given the current rate of emissions. So we can start to explore 30 different climate change impact indicators. And as I mentioned, these can be related to heat and cold, wet and dry, coastal. So we've got things like storm surges in there from Deltaris's storm and surge model. This information is aggregated here at the NUTS2 region, and what we can explore here. So if you, for example, you wanted to do a regional assessment, you could select your particular region of interest, and you can get this information for your given region, for a given climate impact indicator of your choosing. And here you can start to explore and download the data. So here we can get CSV formats downloaded for a particular region. So you can build up time series based on the pre-selected time horizons and reference periods of your choosing. And that is it. So it's really just a whistle-stop tour of what we're doing in C3S, or part of what we're doing in C3S to support climate adaptation. Of course, there's much more information there, and this is a particular case study of how we're supporting the EEA, but we're also doing similar activities for the European Investment Bank, for example, but we're also providing sectoral information. We've got a service for agriculture, looking at key climate impact indicators specifically for agriculture and hydrology, for example, as well, in addition to things like energy. So we've got 3 different thematic operational services, as well as access to raw climate information. I say raw. So you've got your reanalysis information, you've got your seasonal forecast, you've got your climate projections, but also your sectorial and impact sort of side of things as well. So hopefully that's a nice little introduction to what we're doing within C3S and how it could be applicable to the activities you're doing at the regional scales. Thank you very much.
Thank you, Sam. I believe our next speaker will be Alan.
Yes. Hello, everyone. Can you see my screen? Is it working right now?
Yes, it's working now.
Oh, I cannot use my camera, but okay, now I can.
Perfect.
So thank you very much, Sam, for this very insightful presentation. I am Alain Mondrian. I'm working at Aerospace Valley, which is, as Michel rightly said, one of the biggest aerospace cluster in Europe, and especially with a focus on the space industry. And the space industry relies on 2 pillars. The first one is the upstream industry, which basically regroups the space manufacturing companies and research centers. But there is also another pillar, which is often less known about the space industry, which is the downstream industry, which gathers companies using space data and services that are related and derived from the space infrastructure. So that's what we are going to talk about today, the downstream industry, and from this downstream industry, I want to begin by showing what space data can look like. It's a very powerful tool, and you can see here the very unfortunate and terrible situation that happened in Valencia last month. So as an introduction, you can see that satellites orbit the Earth and take many pictures of Earth every day. And that's the typical solution that you can have with Earth observation, which is all the data that comes from satellites orbiting the Earth regarding nature, the surface of the Earth, oceans, the atmosphere, etc. So out of the many data we can gather from satellites, there are imagery, and this tool is very powerful for assessing the climate impacts, as some also presented. So you can see here the flood, the size of the flood that happened in Valencia. And it was taken by a Copernicus satellite. We will talk about it just after, which is called Copernicus Sentinel-2. And of course, this data is not raw data. It does not come from satellites like this. There is a need for processing data. And we will talk about this in a minute. So what are the main hazards in EU city? Because my presentation is a bit focused on the urban adaptation, even though there are many commonalities with climate adaptation for regions and local authorities in general. So cities are mostly interested in the temperature variation, so cold extremes, what we call extreme temperatures, so cold and especially heat extremes. There are many losses from heat waves. Actually, the heat waves are the main cause of fatalities in Europe, with more than 100,000 fatalities since in last year. Sorry. And in terms of losses, economic losses, floods are the most important climate risks. So we'll see that Earth observation is interesting for almost, and actually all of those climate risks. This comes from, thanks to Copernicus Climate Change Service, we can assess those risks. But there are also other Copernicus services that can be used. So just a little reminder of the use of Earth observation in the policy making, in the climate adaptation policy making process, sorry. So the adaptation comes from the new adaptation law, adaptation strategy, sorry, which was released in 2021 by the European Commission. Stems from the European climate law that also comes from the Green Deal. So the main target for the EU is to transform 150 local authorities into climate resilient communities. So that's the main indicator for the EU, and this is done through the EU Mission on Adaptation, which we'll talk about later. And it was launched in 2020, I think, or 2021, sorry. We'll see the services it gives to local authorities and also sometimes to companies. But our project Valorada is actually answering those this objective. So the Covenant of Mayors for the Climate and Energy in Europe created a framework to assess where you are as a local authority in terms of climate adaptation. So you can see that there are mainly 6 steps. And out of those 6 steps identified, Earth observation can actually play a very important role in 3 steps. The steps of assessing climate change risks, as we've just seen with Samuel. Also in assessing adaptation options, because Earth observation can help modeling adaptation solutions digitally. And the last one, sorry, of course, is monitoring and evaluation, and we can even add reporting of adaptation policies. Because of course, at the end of a policy, you have to show that your policy measures were effective for the whole community and for your citizens. So just 2 brief examples of how we can use Earth observation data in this policy cycle. So the first one was Samuel talked about it. The Copernicus Climate Change Service can be used in assessing climate change risks. And for instance, here you can see heat maps of Paris in 2017. So that would basically help Paris to know the risk on a very local level, especially at almost the street level. And the second example comes from Toulouse, where Aerospace Valley is operating between other cities. And this example was mentioned in the EU Mission Adaptation portal, because Toulouse created those shading structures last year in 2023, and they used Earth observation to assess the impacts of those measures. So you can see the EO covers the whole policy cycle. Then Copernicus, what is it briefly? Because we've seen the services which are at the end of the value chain, because they provide information, but Copernicus also provides data, raw data from satellites. And this data is accessible, of course, as Copernicus services for free in an open manner. You just have to subscribe online for everyone. And it comes from a big family of satellites that are currently orbiting Earth, and that monitor many different variables of the Earth, taking the pulse of our planet, as the European Space Agency says. And it goes from heat and temperature, like we've just seen, to ice monitoring, or currents in the ocean. There are many different natural data that are monitored. And the aim, of course, is to use them to assess your climate risks, the climate risk of your local territory. So the good thing would be to use those many types of data. There are more than 20 terabytes of data produced every day, which can be compared to the data consumption of 40,000 European citizens. So it's quite a lot. And of course, the best thing would be to use, in an ideal world, to use this data for climate change adaptation strategies. But you can see from a survey that was conducted by the European Court of Auditors at the bottom of the slide, that there are many local authorities that are not even aware of Copernicus in general, not even Copernicus Climate Change Service, but Copernicus in general. So that's what we are trying to address right now, to show that Copernicus has a very important role in designing your strategy. And then we'll see what solutions you can take with Copernicus in a few slides. So the main goal of Copernicus can be to avoid maladaptations, which are adaptation measures that are not efficient, or that have counter effects on adaptation objectives. So, for instance, and this actually comes from a real-world example, an adaptation strategy based on old data is something that can lead to wrong ideas, wrong measures, or, for instance, forgetting the very long-term climate projections can force your local authority to take too short-term measures. So the good practices would be, for instance, to monitor temperature decrease in your local authority thanks to C3S after implementing an adaptation measure. And there are even sometimes the last maladaptation example is an adaptation strategy that is not even monitored or evaluated. So I will spend a little bit of time on this slide because that's basically all the tools from the EU. Of course, they are national and sometimes regional tools for you to work on climate adaptation, but the EU is as part of the EU climate adaptation strategy, very keen on helping local authorities to adapt to climate change impacts and even to foster climate resilience. So beginning on the left, if you are starting from scratch about climate adaptation, you would rather learn more about climate adaptation and benefit from capacity building or trainings or support from some of those initiatives that you can see. So there is, of course, the EU Mission on Adaptation that provides technical assistance. So just reach to us or to them, and they can help you navigate all this data, all those initiatives. They also share stories related to Copernicus, as I've just mentioned the story of Toulouse. So there you can understand how Copernicus can help you in your adaptation pathway. But they can also put you in contact with projects like VALORADA, like us, in order to discover ways to use Copernicus in your local authority. So then if you have this knowledge, this awareness, sorry, I forgot to mention the Covenant of Mayors, of course, is doing also support to local authorities, especially cities, I mean, mainly cities, to draft your adaptation strategy or to conduct climate risk assessment. There is also an initiative called the Smart and Green Cities Initiative by ESA, where you can give your needs to this initiative. They are also implementing a task force for cities, and they also provide some funding sometimes. And they've worked on almost 60 projects across ESA's lifetime. You can find all the links in the presentation I will share, of course. There is also an EU initiative called the Smart Cities Marketplace, where there is a focus group on geospatial solutions. So it includes space data and especially Copernicus. And then if you're a region, you can also meet the Nereus Network, which is an association gathering regions that use space data and especially Copernicus data. So then if you are a bit more familiar with Copernicus and Earth observation data, the next step could be to try to look for funds to implement projects in your local authority. Or I'm also speaking to companies that may attend this webinar. There are also opportunities for you to find fundings, especially through Horizon Europe. That's where climate information can be created in those projects. So so that's what we call climate services, and that's actually what we are developing in the frame of Valorada. So there are many calls currently open. The EU mission on adaptation still has a few years before it stops. I mean, until 2027. Sorry, there will be many calls for you to get involved and use Copernicus. There is also some projects like Climax, where there are 20, I think something like 15 million euros, 20 million euros to realize climate risk assessments, and you can do it thanks to Copernicus, as ECMWF is also a partner of this project. There are also pre-commercial procurements, especially for companies that want to work and to use Copernicus for climate adaptation. So PCP-WISE is a project that aims to use Copernicus and Earth observation to adapt water management policies in local authorities and national authorities. There are also the LIFE program, of course, which is focusing more on implementing green infrastructures. So here more on the implementation of adaptation strategies, green infrastructure like nature-based solutions, dunes, or erosions. There is also they can also fund gray infrastructures, and also help wetland and peatland restoration, for instance. The second, so in the frame of LIFE, there are almost 2 billion euros allocated to those adaptation measures. Lastly, there is, of course, the European Regional Development Fund, which is the most allocated fund. There are almost 12 billion euros in the current EU budget for adaptation solutions. So there you can work also on green infrastructures, gray infrastructures to mitigate the risks. Then, if you are very advanced as a city or as a regional authority, you can, of course, with your own skills and teams, work directly with space data or more space or Copernicus information. Sorry. So we've seen that there are the Copernicus Climate Change Service on what is about climate, of course, but there is also the Copernicus Land Monitoring Service. So where you can assess, for instance, the land cover and land use of your in your territory, the soil moisture, for instance, of your territory, vegetation in your city or region, or again assessing the water bodies parameters like water quality and water level. There is also the Copernicus Atmosphere Monitoring Service, which focuses on air quality, greenhouse gases emissions, which is more on the mitigation part, but sometimes there are commonalities between adaptation and mitigation. Then there is the Climate Change Marine Service, which also focuses on water quality, but more for coastal cities and monitoring the coastal risks for cities and regions. And the last Copernicus service is the Emergency Management Service, where they monitor and have early warning systems for droughts, but also forest fires, floods, and also they have a mapping service, online mapping service. So there are also many other data sources that comes from ESA, Eurostat, of course, because adaptation is also about economic and social data. And you can find them online. Reach to us. There is we are here to help if you need those data. And I think that's mainly that's the main tools you can find. The last slide is about the other project that Aerospace Valley is part of, which is called Space for Cities. So you can put it in the non-financial support tool, because it's an innovative project which is funded by Horizon Europe through EUSPA, the European Agency for the Space Program. And during this project, we've which is partnering with 5 public buyers, which are Ghent, Helsinki, Amsterdam, Guimarães in Portugal, and Athens in Greece. They have identified climate adaptation as one of the most pressing challenges for them. And this statement, so you can see the sub-challenges, they want to use space data, and especially Copernicus, for green and blue spaces monitoring or implementations, heat and other climate risks like floods, but also disaster response and resilience and preparedness, sorry, because I did not mention it quite clearly, but Copernicus is also very important in the resilience. It means after the catastrophe happens, the disaster happens. So this challenge was considered as the second most pressing, just after sustainable mobility. But more than 40 local authorities expressed interest in this challenge. So we are building a kind of community around those challenges, but also from the private side. Space for Cities think there is solutions are much mature to use Copernicus in a business model, because we've seen that during an open consultation, 500 companies or research centers expressed interest for the call of tenders that will be for tenders which will be launched in January 2025. So there are more or less 400 companies and research centers ready to work on adaptation with Copernicus. So there is a real market, and if you're if you have money, which is the last thing, the last step of your climate adaptation process. If you have money, there are currently solutions that are developed and being developed for your local authority to work on climate adaptation. I think I've covered all my presentation. If you have questions, of course, let me know in the chat or let us know. I will just finish by saying that this project, Space for Cities, is a very innovative one for the EU, because it's the first pre-commercial procurement. I don't want to go into details around this, but it's the first PCP which allows, which will buy actually climate adaptation solutions with Copernicus ever. And of course, there is also the objective of using combined Galileo and Copernicus services. So I think we just to show one of the solutions implemented in regions thanks to space to EO data and space data. Heli, from the coordinator of Space for Cities Forum Verum Helsinki, will present one of the use case that could be very interesting. So thank you very much.
Perfect. Thank you, Alan. Haley, when you're ready.
Yes. Hopefully you can see my screen now. At least I can see it.
We can see your screen.
Wonderful. Okay. Good afternoon, everyone. My name is Heli Pondo. I work at Forum Virium Helsinki. It's an innovation company owned by the city of Helsinki. Today I will talk about climate adaptation and social justice. I'm also talking about our digital twin demo tool that we have developed in the Regions for Climate project, and also say something about satellite data that we have used as part of the projects. I'm mentioning green elements in the title because green elements are kind of like the solution we're successing to climate change, and nature-based solutions as well. Okay, so yeah. Okay, so I guess everyone knows here that climate change means increases the probability of extreme weather conditions in Europe, and it seriously has risen. The effects are visible everywhere, and potential risks may occur unexpectedly, as we have seen during the past weeks, especially in Spain. And importantly for our project is that climate risks are not distributed equally, and some are getting a stronger hit, so to say, than others. For example, individuals' age or socioeconomic status or health conditions have a strong impact on individuals' possibilities to adapt. And it's clear also that adaptation and response are needed, and for this we need new innovations, technologies, and attitudes as well. Okay, so in brief, Forum Virium Helsinki, it's an innovation company owned by the city. It's established 2005. We're focusing on smart cities, smart mobility, data, and we are mostly funded by the EU projects, and it's also financed by the city. And if you find this presentation interesting or the topics we're working with, please be in touch with me so we can maybe prepare a project together. Okay, so a few words about our Helsinki Uusimaa demonstration. And in general about the project, it is actually funded by the EU's climate mission on climate adaptation. And in total, it has 12 regional demonstrations, and Helsinki Uusimaa demonstration is led by us or me. And we have developed a digital twin tool to understand heat impact and flooding impact and social vulnerability as well. For social vulnerability, we have used raster data from Statistics of Finland. It's 250 grids. And our demonstration includes different data sets, buildings, land cover, green elements, socioeconomic data, like said, and heat index. Satellite data is used to visualize surface temperatures for buildings and the heat impact. Okay, so what are the positive sides of satellite data? It is relatively easy to calculate. It's openly available, and thanks to services like Sentinel Hub, its data is easy to use and retrieve. Okay, so the drawbacks. Resolution problems with open data may exist. Sometimes data is not available if there are some clouds, and not every day either. It depends where the satellite, about the satellite's routes. Okay, so data coverage is limited in some constellations in northern latitudes, like in Finland. And here you can see a print screen taken from our demo tool. it's about heat impact or surface temperatures for buildings. Okay, and this is an example of raster data. Helsinki perspective, thermal satellite data, and this is the most important satellite data, so I'm talking about it here. It has raised plenty of interest among the city stakeholders. Socioeconomic data combined with heat data is a good way to popularize climate adaptation and heat vulnerability. It clearly shows where the city could address its actions. And our demonstration underlines nature-based solutions, like said. There you can easily see, maybe not in this print screen, but in our demo, you can see clearly the impact of green elements. The surface temperatures are usually always lower among green elements. And there is interest in combining different hazards in the same view. Here we are talking about heat, but also flooding and maybe other hazards could be combined. And this has not much done. Okay, so satellite data value, data availability, to conclude. Data availability, satellite thermal data currently is the only constantly updated thermal data set with the whole city coverage. Data integration, combining satellite data with other sources. It offers new insights into complex phenomena like climate adaptation. And affordability, with open satellite data, no significant data acquisition costs in prototyping applications, so it's almost free. Of course, it requires resources, but yeah. But a true application of satellite data products in cities, it needs new service development and a high emphasis on use case and the ease of use. So you definitely have to cooperate and communicate with the stakeholders about their needs and the development, and before the development and after it. Okay, yeah, thank you. This is my email, and my colleagues details as well, who has actually helped me to prepare some of these slides. Yes.
Thank you, Haley. We'll just wait for a few minutes for the questions to come in. I do have 2 questions. And the first one is for both you and Alan. You have presented really a number of EU-funded projects and the relevant climate tools. And thinking about the floods in Valencia, I was wondering, in your opinion and in your experience, what is the best way to work with decision makers to provide them with real-time data?
Sorry, I think what was this question for me?
For both you and Alan.
Yeah. Okay, sorry. Sorry, could you repeat the question, please?
Of course, I was just wondering what is the best way to work with decision makers and policymakers and provide them with real-time data? Because in the tools you have showed us, these are monitoring, but based on data that has already been processed in the past.
Yes, actually, this is more about prevention and adaptation in advance, not reacting in a case of a hazard. And you're right about it, that it's basically historical data, even if it's not like really old, but it's not very, very new. But maybe some sensor systems, they could warn. And we also are using some sensors as well, but it's not the core of our project.
Yeah, absolutely, if I may. We've come across this topic during Space for Cities consultation, as the Helsinki and all the public buyers want to have as much as possible real-time solutions. And of course, with Copernicus, the current state of the current capabilities of the Copernicus satellites, it's not very possible to, I mean, it does depend on your definition of real time, but it cannot be under the day time of revisit for satellites. So especially with Copernicus, so I don't think it could have helped with Copernicus, even though there are projects, experimental projects, trying to use AI and trying to define the needs of local authorities. If there is a big need for real-time solutions, then maybe that's something that the EU can fund and something that needs to be taken in account at the EU level. But I think the best solution would be an early warning system, and I didn't follow very much what the cause of the Valencian floods was, but maybe there was an issue there.
Thank you, Alan. And I also have a last question for Sam, just relating back to the user community. So from the result of our poll earlier, most of the participants would prefer if the data is already processed and readily available for them. Considering your work with C3S and CP, what are the most suitable learning resources when it comes to non-technical experts? Maybe policy experts, and are there any upcoming initiatives ECMWF is working on that would support this community?
Yeah, so you got a few. I'll unpack that question. I'll try to remember exactly what you asked. There's a few different questions in there. So yeah, I mean, most people, because I think dealing with climate information is very different from dealing with satellite information, for example, or even weather information. You can't use a climate projection like a weather forecast. You have to deal with it and process it in a certain way and understand how to interpret the results. And this is why people use reference periods and time horizons and multi-models. So in that respect, we will be, well, we're looking into the possibility of publishing the summary statistics to support data users or non-expert data users, or those who just wish to have readily available information through the CDS. We're also looking to potentially explore different formats as well, shape files and geotiffs as well. So it's not just the climate community or those who used to using NetCDF can access the data, because I do think data manipulation and data formats is a barrier to uptake. And yeah, not everyone is au fait with climate projections. So that's one aspect. The other is the NCPs, the National Collaboration Programme, is something I'm coordinating at C3S for the C3S NCP, and it's just in its infancy. What is particularly interesting is that the European landscape is very different. You have countries who have very mature climate services, who have their own high resolution climate projections, who are supporting climate adaptation strategies and are updating them. And this is true for I'd say probably about 15 European member states, or half the member states. Then you have those that are cooperating with others to gain their expertise, and then you have others that are still in the capacity development stage. So the NCP will be working with national contact points to really work with those to address their own specific needs. There's not a one size fits all. It's the NCP is really the collaboration part, and that's the key thing. So we work with different member states according to their own needs. So if there is anybody here that does recognize the need for climate information tailored to their own purposes, and C3S could help, then I would encourage you to get in touch with your Copernicus user forum representative. I don't know who that will be, but it's various people across different countries, and they report back to Copernicus, the DGs, but also the implementing authorities, in this case, ECMWF. And we can then start the bilaterals and talk about needs and requirements, and we can reflect those in the upcoming calls. And I think there's a third part to the question, which I can't remember. Sorry, Michelle.
No, you have answered my two questions.
Okay, perfect.
Thank you. I do not see any new questions in the Q&A function. So I believe that the speakers have addressed all potential questions perfectly in their presentations. I just like to thank the speakers for sharing their insights and for also the participants for joining us today. If you have joined us for both webinars on the Climate Risk Data and Assessment series, we would like to hear more from you, and we appreciate if you could fill out the survey in the chat to help us improve our future capacity building activities. Thank you very much. We're ending the webinar here. Thank you.
Thank you. Have a nice day.